Hello everyone, welcome to the channel. In this video, we'll look at how to incorporate the concept of end releases in SAP2000 in an example problem. So we'll look at a continuous beam which is fixed on one end and which has a roller support on the other end. So in that particular beam, we'll introduce a hinge in the middle using the concept of end releases. I have chosen an example from Hibbeler's structural analysis book to show this concept. Before we proceed, I highly recommend checking out my previous video on end releases for some essential context. I have set up the grid spacing as same as the example problem. We'll go to frames and I'll draw a frame with the default properties. Now select the end on the left side and I'll assign a fixed restraint, and on the other end I'll assign a vertical support only. And now this is the node where we have to assign the hinge. Now I'll double click on the frame and under releases I will select the end release under the moments, and for the other frame I'll double click again and choose the end release, but in here I'll choose the start end release here for the moment. So I have released both the moments at this node, so we have formed a hinge at this node. Now I'll select the frame and assign the load to the member. So I'll go assign in frame loads and I'll select distributed loads, and similar to the example values, so I'll define this load keys as live and assign the live load of 400 pounds per feet. Next, I'll select this app node and assign the moment to this node. Next, to find the local axis about which we have to apply the moment. So let's select the local axis and then see the axis about which we have to apply the moment. Now looking at the local axis, so if we consider the right hand coordinate system, so the moment will be applied about the green axis, which is R. Green is axis number 2, so RGB, so axis number 2. So we have to assign the moment about the axis number 2. So let's go to our forces and then assign the moment of 6,000 pounds feet at this particular node in global y direction. Now we'll run that program and I'll have the dead load and live load both switched on, but if you remember, all our loads has been assigned to the live load. Now we'll run the program. And that's the deformed shape of the model. We'll check the node joint reactions under the live load condition. Now if you compare the end results with the example problem, both the results are same. But go and select the show results for the frame and choose the shear in the total direction. So now we can see the reaction in the middle hinge. So the reaction is 400 pounds in this location. This is also comparable to the example problem results. Well, that's it for the example. Thank you for watching this video. If you like this video, please like and subscribe and stay tuned for more similar examples and more videos.